again, if we say that, what do you mean by that magnetism or that magnet? So basically simple, I can say that it is a property of your certain substance, so which can attract or repel the material like your iron, cobalt and nickel. So if I say that, so let's say that you can say there is one your magnet, and definitely then I can say this magnet is going to attract your small pieces of your that iron, cobalt and nickel. So definitely suppose if I just put some pieces over here, so definitely it is going to attract it. Likewise, the one which we have seen in case of your electric field, the similar onto that. So this is nothing but your the property of that substance. Now we are going to call it as a magnetism. Then magnetic field. So if I consider, let's say this is the magnet, then definitely it is going to produce a certain field. You can say that. So let's say this is nothing but the field around this magnet, where those other particles, where iron, copper, that nickel, yeah, it will experience some force. So it is a region around this magnet where other substances will experience some force. So this field around this magnet, we are going to call it as a magnetic field. And again, this field we are going to represent with the help of those magnetic lines of force. So that is about the magnetic field, which we can say that. So one more thing, important thing, so that magnetic field, again, this is which has been produced by this your magnet, and this magnet we will call it as a source of your magnetic field. Now along with that, there is another source. So the mainly the magnetic effect of current. So why we are saying that it is a magnetic effect of current? So there was a scientist whose name was nothing but the Oersted. So what that Oersted he has done, so he had just taken, this is the current carrying conductor, and he placed one needle near to that current carrying conductor, and he found that this needle has got deflected. So then basically you can say that this needle, obviously it is a magnet, and if it is getting deflected, so definitely there has to be presence of some another magnet over there. So suppose if I try to bring these two magnets closer to each other, then definitely you can say there is a repulsion. So the same thing is happening over here. If this needle is getting deflected, so obviously there has to be some source of magnetic field near to this current carrying conductor. So you can say that this current carrying conductor will act as a source of magnetic field, and which will produce the field around it, and because of which the needle is getting deflected. So that is what we are going to call it as a magnetic effect of current. So that means again we are saying that is magnetic effect of current means the current is responsible. Again, what do you mean by current? So we are just saying that current is nothing but the charges which are in motion. Again, the electric charge is nothing but your electrons, the electrons which are in motion. So definitely that means I can say that if the charges are in motion, then they can produce the magnetic field around it. Or even you can say that if the two charges, if I projected with a certain velocity, then definitely there has to be some force. You will find some force is exerted between them. So that is nothing but the magnetic effect of your current. So the basic thing is that, so that Oersted has proved that, so this current carrying conductor will act as a source of your magnetic field. So now then I can say that I am having two sources of magnetic field. One is nothing but the simple bar magnet, and another is nothing but this is the magnetic field which is produced by your current carrying conductor.